Hey guys, I do welcome you guys to a new video. In the last video we have discussed about the diffusion and effusion and all the concepts related to the topic. So I do hope that you have watched the last video and you have got the concept. I did explain it with the help of various diagrams and all that. If you haven't checked out that video, do check that out. And in today's video we have got some problems related to the topic that are very important. Uh, so for this I do remember this one as number one and this one is the number two, and let's get into it. The number one solution for there over here, let's look into the question. Find out the ratio of the rate of diffusion. Now it's asking for the ratio of rate of diffusion of helium and CH4. Now we know the formula. uh, we have got two formulas. We have discussed two formulas yesterday, and we have got comparison of two gases. Then we can write, uh, when we have comparison of two gases, we can write R1 upon R2 is equal to radical M2 over radical M1. Or we can write, if we have got the densities, we can write radical D2 upon radical D1. This is how it works. D1. Yes, these were the formulas. Like we can use this one, or the mass factor, or we can use the density factor. In this we are not given the density, we are not known about that, so we will be going for the mass factor. Now R1 and R2, for this I am going to write over here R, sorry, for this I am going to write over here R He helium, R He helium, and R CH4, right? And when I put these formulas in the values in the formula, then I will get the mass of CH4, over mass of helium, right? So let's get more into it. This is quite simple, right? I do hope that you have got how to do this. This will move in this, we'll put values of it, helium over, sorry. Okay, so yes, we are back. So R helium over R, this one, that would be equal to, uh, radical, what is the mass of CH4, that is 12 plus 4, that is 16, radical 16 over radical, uh, radical or the helium one is a 4, so radical 4. Now if we solve it out, we'll get 2 upon 1, so the ratio would be 2 ratio 1, 2 ratio 1, right? And the helium has got the ratio 2, this is how you're gonna determine the answer. Helium has got the ratio 2 and the CH4 has got the ratio of 1. This is your answer. And the second one is also quite simple problem. Find the diffusion of helium, CH4 and SO2. So I'll be doing one for you, then the rest two are your homework. We are given three cases, we cannot do comparison directly, so we'll be using, for suppose I've been asked for the helium, so this is the question number 2, R helium, so this will be equal to K, here the constant K comes, and K over radical He, that is the inverse relation, right? M of He, will become over here, and this would be equal to k over radical 4, and that would be equal to k upon 2, k upon 2 radical 4. Sorry, this was a radical 4. Sorry, this was a radical 4. Radical 4. So that would be equal to k upon 2. When you will find the rates of diffusion of the CH4 and SO2, you'll find some values like k upon y, or k upon z for the other one, SO2. Then when you will compare these, you will get to know that you will get a formula like here I first like the helium 2 ratio y ratio z, so that the value of y and z, that is your task. You need to very simple, that is write k upon CH4, then we write molecular mass of CH4, then find out the square root, then you'll get your answer. Then you need to compare them and do right over here. I do hope that you've got the concept. If you did, do like the video. Meet you guys in the next video. Till that, goodbye.